When we looked at inverse relations in the last lesson, we kept our definition really nice and broad, and that's because some functions will have an inverse that's actually not a function, but it'll still be a relation. And we saw that there was 4 different types that we could have based on whether they were one-to-one, one-to-many, many-to-one, or many-to-many, and what their inverse would then look like in each of those 4 scenarios. Now, if a function is one-to-one, then we know that its inverse will also be one-to-one. So there's some special notation that we can use, but we only use it if we've got that situation of both the function and its inverse both being one-to-one, because that's the only occasion that both of them will actually be functions. Now, what we'll do in this case is we'll write f with a little -1 up there of x. Now, we've seen that to the power of -1 normally means 1 over something. So we need to be super careful here because we've already looked at this notation. When we take y equals f of x to the power of -1, that means 1 over f of x, doesn't it? So this one would be also written like this. And we know that that's a reciprocal function. And to take the reciprocal of something, you just create a fraction with 1 on the top and then you put whatever you had on the bottom. Now this doesn't flip the graph upside down, so be careful not to confuse these inverse functions with reciprocals or just with vertical reflections. That's another thing entirely, where we replace y with -y. Now, the reciprocal function has its -1 up there after the entire thing, and I think that makes sense that that's this one. Now remember that an inverse function is actually a reflection of your original function around the line y equals x, and that's because all the x's and y's in the formula swap places. So this new notation that we're learning today, we need to be really careful not to mix that with this one. This one is the inverse function, and it has its little power of -1 in between the f and the x, so that's something a bit new. Now, a concept, we've already considered this, but let's just consider it more formally now. If we're applying an inverse function, and remember that applying a function, we originally reasoned that it was like putting something through a function machine and it did something to the x. Well, if we apply an inverse function to any number, then it basically is just sending it backwards through that original function machine. So I think this picture hopefully makes some sense. In the beginning, we said, well, when we're looking at functions, let's imagine it like a function machine. We have inputs and then we have outputs. And if we put an x through an f of x machine, what we'll get is the function of x. So it will apply that little recipe of what we're doing to the x to it. But if we then take that and put it backwards through the machine, that is what applying the inverse function really does. So I've called this here an f of x machine when it goes this way, and an f to the -1x machine, or an inverse function machine, when it's going backwards. So then erasing both things here, we can see that if we start with an x and we go through the machine but then back through it, we should end up with an x. What did we call this? We called it f of x because at this point it's just been through the f of x machine. But if what we'd started with over here was an x, then it makes sense that if we go through the machine in both directions, we're going to end up with an x. That makes sense. What would we call this? Well, we'd call it the thing that's just been through the inverse function machine. It would look like this. So hopefully that makes sense. Going through the machine in 2 different directions, no matter which side you start on, is going to give you exactly what you started with, whatever that was. So we can write that in 2 different ways. We can say the f of the inverse function of x is x, but we can also say the inverse function of f of x is just x. So we'll have a look in a minute at how we can actually prove this for any inputs that we like. Now, the other skill that we need today is we need to be able to find an inverse function using this notation, the f to the -1x, from any original function. So 4 steps. We're going to start by just changing f of x to y, because we know that in the original function, if we've got f of x equals something or y equals something, it's the same thing. So f of x really is y, and we're going to just change them, just to make it really simple. Then once you've got your x's and y's, the second step, which we've already seen how to do in the last lesson, is we just swap all the x's and the y's in the formula and in any conditions that you might have. Now it should read as x equals some stuff that's got a bunch of y's in it. Next step is to rearrange that to make the new y, which used to be the x's, remember, the subject, so that it still reads as y equals some stuff with the x's on the other side. And then last step is to say, hey, but our new y is not actually the same y that we had up here. It's the inverse y. So we're going to now call it f to the minus 1 x. And that way we'll have our inverse function notation for that inverse function. And now an example. For this particular function, we need to prove that both of these statements are true. So in either case, the first thing that we need to do is actually find the formula for the inverse function. And we'll use that new notation that we've seen. So step 1 is to rewrite it with a y instead of the f of x. And now you can just swap all the x's with the y's. So that gives us x equals y cubed plus 2. Now let's get the y on its own. So we'll start by subtracting 2 from both sides. And now to get the y on its own, we need to take the cubed root of both sides. So I'll write it as y equals the cubed root of x minus 2. And at that point I can say, well, that means that f to the minus 1, x, or my inverse function, equals the cubed root of x minus 2. So now for a, I can start with what I've been given, and then on the next line I can sub in what I have for the inner brackets here, which is my inverse function. So instead of writing that, I'm going to write the cubed root of x minus 2. And that effectively means I need to put the cubed root of x minus 2 into the original function. And anywhere they had an x, I'm going to put this. So that's the same as taking my cubed root of x minus 2 and cubing it and adding 2. Now I know that cubing something and having the cubed root are opposites of each other and they'll undo each other. So effectively now I just have x minus 2 plus 2 and that gives me x. So I'm finished, I write as required just to show I'm done. Now for part B, I'm starting with the inverse function of f of x. And that's the same as the inverse function of, well, what is f of x? We've got a recipe for that up here. It's x cubed plus 2. Okay, so what does that really mean? Well, that means that here we've got a recipe for our inverse function. It says to do this. Anywhere there's an x, we're going to put it in here. So what we need to put in instead of x is x cubed plus 2. So we rewrite this formula, cubed root of, now when we get to the x part, we're going to write x cubed plus 2. And then we've got the minus 2 also in there. So that gives us all of that. Now tidying up, the plus 2 and the minus 2 will undo each other. So now we've just got the cubed root of x cubed, which of course is x as required. And we're done. So it's quite a straightforward process as long as you keep straight in your mind what you're doing. And remember that if you've got your formula for your original function and you've got your formula for your inverse function, then just take care of the inner brackets first by replacing them with something that's equivalent, and then sub in what's in your brackets into whichever function you need. And it's important to remember that in a question that says prove that or show that, and they give you what the starting place is, but they also give you the answer, the marks are never going to be for the actual answer. The marks will always be for the working that comes in between. So don't be tempted to take shortcuts or do any steps in your head that you might when you're looking for an answer. For example, if you were just solving this and you got to this point, you might be tempted to write, oh, plus 2, minus 2, I can do that in my head and see it's not worth writing down. But in a prove that question, you need to write down your plus 2 and minus 2, even if you then cross them out. So it's really clear to an examiner that you understood where that x actually came from.